This is part 2 of Lesson 5, Chapter 5, Network Security Implementation. In this part, we will discuss various different administrative controls. These include corporate objectives, policies, procedures, standards, guidelines, training, and awareness. The first of which is authentication. Authentication is a verification of your identity, such as a driver's license. The most commonly used authentication method in all of computing, of course, is the username or user ID and password. And even though it is the most common, it is also probably one of the most weak methods. And the reason is, of course, the weakness of our passwords. A lot of people will not include upper and lowercase alphabetics. A lot of people don't include numerics or don't include special characters. They use common words or phrases. They use perhaps phrases that might be familiar to somebody in their family. So we have passwords are quite weak. They can be made strong. The problem, of course, is that the stronger you make them, the harder it is to remember them. We have multi-factor authentication, which is, of course, something you know, such as a password or a PIN, something you have, such as a security token or an ATM card, or something you do, or something you are, biometrics or behavioral based. These could all be combined together as multi-factor authentication in order to make it more complicated to actually authenticate one into a system, and thus make it more difficult to hack or crack that authentication. A common multi-factor authentication method that's used today, often called two-factor authentication, has to do with the use of a user ID and password to log into a system, but then a random code is then sent to a predetermined, usually a smartphone, as a text message, and then you use that 5, 6, 7, 8-digit code to then enter into the system, and then you're granted the entry into the system. Usually those codes are only good for a certain period of time, maybe perhaps 5 or 10 minutes at most. And so the user has to go ahead and enter the system as quickly as possible. Otherwise, they have to back out, enter their username and password again in order to have texted to them a yet another authentication code. Authorization. Authorization is concerned with what one has access to do. Once you're into the system, what can you do with it? What files can you access? What files can you update or delete or change or add records to? What programs can you execute? So authorization is important because once you're in a system, we have to limit what you can do with it. Least privileges, that concept is very important. It concerns the access to what one needs to complete one's job. In other words, which programs are you limited to that you can execute? Which files are you limited to do your work that you can access to complete your job, and only for those purposes? It says here that authorization typically occurs after authentication. In fact, it almost always occurs after authentication. Once you're into the system, we're not just going to let you do anything. You have to be authorized to do certain things, and so it does occur after authentication. Here we see an example purchasing beer. The clerk checks your ID to verify the picture match, and we hope that you're not using a forged picture or a fake ID, and that's authentication. They authenticate you as to who you are, and then they check your date of birth to see if you're greater than 21, which would be your authorization. Accounting. Accounting is important because what we're doing in accounting is we're logging what you did once you got into the system. We're logging all attempts to get into the system that failed and all that were successful. Who did it, what they did, when they did it. Checking for compliance to ensure appropriate access to the system. Monitoring to look for violations, and checking for unauthorized access to the system. Encryption. We had to worry about data at rest, encrypting data that is at rest, including files, database encryption, disk encryption, and data in transit, ensuring integrity, confidentiality, and privacy, ensuring non-repudiation. You cannot say that you didn't send that data. Encrypted tunnels, IPsec and SSL TLS. One thing that's important to remember is encryption is not only concerned with confidentiality and integrity, is only concerned with confidentiality and integrity. Unlike other areas, there are not any availability implications with encryption. So data is encrypted to ensure that it's confidential, and to ensure that it's whole and complete. It isn't encrypted in terms of making it available to the user. Endpoint security. A node is any device on the network, even those without an IP address, while an endpoint in IP nomenclature does have an IP address. Different types of nodes require different types of security, and the security of individual devices creates greater network security. Endpoint security concerns include clients, such as antivirus scanners on those clients, firewalls, screen lockout and physical lock, and on servers, redundancy, strong authentication, and physical isolation of the server, and perhaps a server room that only certain people have access to. Also, networking devices, routers and switches, strong authentication, accounting, and of course physical isolation. You want to keep your networking devices away from anyone else, any people that are not authorized to access them. Some of the roles involved in endpoint security include end users. You have to have your acceptable use policies to ensure that they do what they're supposed to, and you have to make sure that they understand what's involved with security, and that they are aware of what the security threats are. A security awareness program is important for all of your end users. The systems administrator, that person is responsible for the implementation of endpoint security. The network administrator is responsible for the networking devices, and the physical security staff is responsible for any physical controls. So in summary, in Chapter 5, we learned why layered security strategies help mitigate risks, threats, and vulnerabilities. Layering security to provide enhanced security for enterprise network resources. Practices for hardening systems and networks against an attack. Security is a process rather than as a goal, and security is a process or life cycle that requires constant attention.